So let's look at an example of using the ratio test. Here we have something 3 to the n over n factorial. And again, thinking of strategy of all the things we've talked about that you could possibly try on this series, it almost looks geometric, right, because of the 3 to the n, but there's other stuff in there. 3 to the n would be a divergent geometric. Dividing by n factorial would make it even smaller, so comparison with the geometric doesn't make sense here. It doesn't look telescoping. Integral test is out because factorials are only defined at the natural numbers, so there's no integration to do there, which means integral test is out. It's not anything like a p-series. DCT and LCT tend to be stuff that we compare with a p-series or geometric. So all the things we've looked at, nth term test, well, remember this was in theorem 5. This goes to 0, so nth term test is inconclusive. So really nothing that we've looked at so far would work on this series. So let's take a look at ratio test. And actually, as we'll see, things with factorials often work great in ratio test. So first of all, remember ratio test requires positive terms. So I want us to confirm that first. So 3 to the n, 3 to any power is a positive number, and the factorials are all positive. So that guy is always positive. What about the limit? So let's figure out what rho is. Our rho is the limit as n goes to infinity of a sub n plus 1. So 3n plus 1 over n plus 1 factorial over 3 to the n over n factorial. And when you do these ratio tests, often the very first thing you're doing is flipping to make this a proper fraction. So let's do that. So we're going to have 3 to the n plus 1 times n factorial over 3 to the n over n plus 1 factorial. Those 3's cancel nicely, right? This is just 3. Right? We have one more 3 up top than we do on bottom. And as we saw when we were reviewing factorials, these ratios of factorials cancel nicely because this is the product of 1, 2, 3, 4, 5, 6, 7 all the way up to n. This is the exact same product except for one more factor. So everything cancels but that n plus 1. We have this nice simple expression. Limit there is 0, which we want this to come out to be less than 1 for convergence or greater than 1 for divergence, and this one is less than 1. So our series 3 to the n over n factorial converges by ratio test. And you can see what I mean about factorial often working nice in these is because of that way factorials cancel. Also, exponentials work great too. So this has two of the best things for a ratio test because so much just cancels off. It makes evaluating that limit easy. And so we've got something that's convergent by ratio test. Now, if this comes out to be 1, then as we saw in the proof, p-series will always come out with a rho of 1. So if this comes out to be 1, often what that means is what you're dealing with is something that's either a p-series or close to a p-series. So all is not lost. If that comes out to be 1, my next thought would be, do I have a p-series, or maybe I can do an LCT or DCT with some p-series? So be thinking along those lines if this comes out inconclusive. And we'll also look at, in a moment, a test that's very similar to this called the root test. We'll look at that as well. It has some of the same conclusions.